Welcome to your second video on hyperbolas. Right now we're going to do an example, and let me zoom in here a little bit for you. So if you are given two vertices of 3, 2, and 3, 6 and a conjugate axis of 10, we're going to find the equation. So you need to remember your vocabulary, and the conjugate axis was equal to 2b. If that's a distance of 10, then you know b is 5. So you can then make that substitution into your equation very quickly. But if you have the vertices, you need to find the center before you can even set that up. So let's quickly kind of sketch this out a little bit. If I go over 3, up 2, and over 3, up 6, 2, 3, 4, 5, 6, and I have vertices there, I can easily see that my center is at 3, 4. So that will be helpful. And right here, I can see that A is going to equal 2 on my transverse axis. Well, those things help us set this up perfectly because I can see that it's vertical. So I know I'm going to have Y first, and I'm going to have Y minus my K, which is 4 squared. And that's going to then have the X minus the H, which is 3 squared. And the first term is always over the A squared. A is 2. 2 squared is 4. Minus B, this over B squared, which would be 5 squared, 25, equals 1. That's all there is to it to get that equation. Let's do one that requires a little bit more, and we may have to complete the square on this one. We will, as a matter of fact, twice. So when we do that, we have this problem that if you notice, the Y is first, so that's going to be our positive term, and I've got two Y's. Here I have two X's, an X squared and an X, and I'm going to need to complete the square twice in order to find the center, the vertices, the foci, and the asymptotes. So it's similar to when we did this on the ellipse. I am now going to gather my Y's together, and in doing so, I'm going to factor out the coefficient of the first term, that's 25. So I'm going to have 25 times Y squared minus, or no, it's plus 4Y, and I'm going to add to that some number to complete that square. I'm going to pull out a negative 16 from my X terms here. I'm going to have X squared. Now when I factor out a negative 16 out of a positive 96, I'm going to get a negative 6X. And again, I'm going to add some magic number there. This is going to all equal my 444. Let's try to figure out what this magic number is. Remember, it is B divided by 2 squared. So half of 4 is 2, squared is 4. But I'm not really adding 4. I'm really adding 4 times 4, which is 100. So if I add 100 here on this side, I have to add 100 on this side. Here, this magic number, half of 6 is 3, squared is 9. But it's not really a 9, is it? It's really negative 16 times 9. Well, if I'm subtracting that over here, which is 144, I have to subtract that over here. Well, that's going to give me 400 on the right side. Now let's write the left side with our squares, because we now have here, we're going to have a negative 16 times X minus 3 squared equals our 400. And then we're going to have, here we're going to have a Y plus 2 times 25. So we now have this equation right here, and we are going to need to divide all 3 of those by whatever value this is, because we need a 1 over here. So I'm going to divide by 400. And sometimes these numbers come out very, very nicely. And this is one of those instances. 25 goes into 400 16 times. 16 goes into 425 times. So our final equation comes down to y plus 2 over 16 minus x minus 3 over 25 equals 1. Now let's figure out what we needed. We wanted to find the center. We wanted to find the vertices. We wanted to find the foci. And we wanted the asymptotes. So in doing that, I am going to need to kind of get a sketch of this graph. And let's kind of come over here. I'm just going to use that red line. I'm going to make my center, which I can identify right now. This is a very common mistake, is people look at this and they grab the first term as the h. But you got to look to see what's with the x. So our center is really at 3, negative 2 here. So I'm going to go over 3, down 2, and that is going to be my center of my hyperbola. I am now recognizing that a is 4, because a squared is 16, and it's under the y. So I'm going to go up and down 4. And you know what? I think I'm going to make my graph, I'm going to go a little bit bigger. I'm going to say this is 1, 2. So I'm going to go up 4. 1, 2, 3, 4. I'm going to go down 4. 1, 2, 3, 4. So those are my vertices. Put little V's there to remind myself. I'm going to go left and right by 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm going to make my box. I'm going to make my asymptotes, and you can tell that my box is not very square. I did not do a very good job sketching this out. I apologize. All right, and I know it's vertical in nature, so the branches of the hyperbola would be doing this kind of thing. And they would come up from here and go down. All right, let's try to find some of these other characteristics. The vertices would be over 3, and this would be at 2. So 3, 2, and 3. If that's at 2, negative 2, then I'm at negative 6. All right, my foci, I need to figure out what C is. So you have c squared equals a squared. What b squared with a hyperbola? Remember? It's plus. And this part's easy because you can pull these right off of the equation. So you have a squared, which is 16, plus 25. So you have c squared equals 41, or c is equal to the square root of 41, which is about 6.4. So when you graph that, you're going to come 6.4, 6.5, whatever, from the center. Well, we've already gone up 4, 5, 6.5. So there would be my foci, one of them. I would come down 4, 5, 6, and a little bit more. There's my foci. So when you are writing the point, you know it's at 3. Is your x value of those foci. But you can just say, oh, you're at negative 2 plus or minus this, that c value, plus or minus the square root of 41, I'll say. All right. Your asymptotes, remember the asymptotes cross in the center, so that's the point that we're going to use when we write the equation. But let's talk about the slope. The slope is rise over run. Well, that's our a value over our b value. So for the asymptote, you're going to use the point, which is 3, -2, and you're going to use your slope of 4 over 5. All right, but it's going to be a plus or minus 4 over 5 because it could go this way. So you have the slope of rise 4, run 5. So when you make the equation, you have plus 2 equals plus or minus 4/5 times x minus 3. I guess I should have written that up there. But that would be your asymptotes. That would be the equation of both of those lines if you take the positive slope and then you take the negative slope. Okay? That did quite a bit with that one equation. And again, you can tell that's a hyperbola because you have two squared terms and one of them's negative. So you know that's a hyperbola. All right, let's do one more example. This is an example that has an application using what we call the long-range navigation system, or LORAN. And it's for ships relying on radio pulsars that's not dependent on the visibility conditions. So if your LORAN stations are, we're going to label them E and F, and they're 350 miles apart along a straight shore with station E due west of F. So if we draw that and we put the stations along this line, and we're going to say here's E and here's station F, we are going to arbitrarily put the center of the origin, so to speak, of the graph. We're just going to arbitrarily make that in the center between the two stations. So that's going to be our origin, and this just makes it a little easier to graph. But some things that we need to note. When you do the LORAN program, or process, the stations that are sending out these radio pulses, the stations are at the foci. And that's important. Stations at the foci. Because it just told you that those stations are 350 miles apart.